Welcome to the second session of the SQL for Data Scientists book walkthrough series. This is Renee Teat. I'm the author of the book. I'm also on Twitter at Becoming Data Sci. Today we're going to focus on chapters 1 and 2 in the book. So the first session focused on setting up MySQL Workbench. Now we're going to go into the book a little bit, talk about some of the queries, and I'm also going to answer questions that people submitted on Twitter. You can also submit them on YouTube. So thanks to everyone that submitted questions. We're going to go through them now. So the first question is really for before you even pick up the book. If we know R and Python, why is it also useful to know SQL? What is the extra that SQL gives you? So thank you, Judith, for your Twitter question. Basically, you can do a lot of analysis with SQL, which you can also do in R and Pandas and Python, for example. But SQL is really for retrieving data from a database. So if your current analyses all start with a CSV file, you're starting by importing data into your script from a file, not from a database. You're not pulling from a relational database or a data warehouse, and it's pretty likely that on the job, you're going to have to create your own data sets from a database. So unless your job has a full data engineering team that can do that all for you and you write the specification of what you need, they give you the data. And actually, even if you have that, it's still good to know SQL, because if you don't get what you need, you can tell them exactly what needs to be changed in their language. So it helps you communicate with data engineers. But really, you'll probably be expected to create your own data sets from a database, which is really what I'm teaching in the book. By the way, you can also use SQL in R and Python. So even if you already use those languages, learning SQL will enhance your skill set. So it's really kind of the step before you get to analysis is creating and compiling your data set for use in your script. Okay, so chapter 1 in the book. The questions that are starting on page 9 in the book, these can be used in real life scenarios. So this chapter is kind of more conceptual. You don't actually get started in writing SQL yet, but when you're looking at what's on page 9, I kind of give an example of some of the questions you can ask people like at work when you're first starting to work with the database. So that is kind of applied, even though the chapter's conceptual. That's something I hope you can refer back to when you do first get access to a database at work and need to get some information about it. I also wanted to point out, we're going to go through a little bit of the exercises at the end of the chapters throughout the series. The answers to those are at the end of the book. So in the printed book, it's on page 239. You can flip back there and see answers to any of the exercises at the end of the chapters. So in chapter 1, exercise 2 says, think of something in your life that you could track using a database. What entities in this database might have one-to-many relationships with one another, or many-to-many? So in the back of the book, the answer is talking about an exercise database. So you can have a table of workout sessions and a table of exercises. That would be a many-to-many relationship. So each workout could contain multiple exercises, and each exercise can be part of multiple workouts. So if you included a table of the workout session locations, that could be designed as a one-to-many relationship with the workout sessions table, assuming each workout could have only one location. So in this supplemental video, I actually wanted to take a step further than we did in the book and draw a little relationship diagram of what this kind of database could look like. Now I'm trying to keep this video short, so we're going to do this a low-tech way, and I'm trying not to spend too much time on these videos so I can make sure to make them on time for you. But basically, here's a layout of 3 tables you could have in a database tracking workouts. So you can have a table of exercises. Each of these is a unique specific exercise. So you have the exercise type, exercise name, the description, and you give each of those an ID, which is the primary key. Then you have specific workouts. So this would be a workout date, a location, and you could have an auto-incrementing number there that serves as the primary key. You could use the date as the primary key if you only have one workout per day. But just in case you do more than one workout in a day, you might want to use some sort of ID other than the date. So how do you connect these two? So you need this junction table here, where you've got the workout number from the workouts table, so that's a foreign key, you have the exercise ID from the exercises table, so that's a foreign key. And then you're so you've connected these two tables through this. This is a record of in every single workout, every single exercise you did, and how much of that exercise you did. So at first I had this as the number of reps, but I realized some of the workouts might be, for example, jogging, and you might want to track how many miles you jogged or for how long you jogged. And so that could be, the amount could be like a count, and the amount type could be number of repetitions. The amount could be miles, and the amount type could be, number of miles. The amount could be a time, and the amount type could be number of minutes. So this makes it more general when you're designing the database to have any type of amount possible. And so here you would have, from workout number to workout number is like a one-to-many, and from exercise ID here is one-to-many. And the way to read this would be, for every row in the workout details table, you can only have one workout. But for every workout, you can have many rows in the workout details table. For every row in the workout details table, you can only have one exercise ID. But for every exercise, you can have many workout details. So this is a one-to-many, this is a one-to-many, but from the point of view of entities, exercise is an entity, it's a thing that we're trying to track, a concept. Workouts is an entity, it's a thing we're trying to track, it's a concept. And between exercises and workouts, concepts, that's many to many. Each exercise could be in many workouts, and each workout could contain many exercises. So that's a real quick explanation, but that's an example of, a little database you can design to track something in your personal life. Okay, so speaking of tables and entities, we have a Twitter question from Andrea Urban. Sorry, I don't know if it's pronounced Andrea. That's actually my sister's name too. I'm reading through chapter 1 and having trouble with the dimensional data warehouse definitions. Fact, dimension, entity. Is entity different from table here? This is definitely confusing to a lot of people, and I know some people don't like to hear this, but I would say for right now, don't worry about it. Like basically, table and entity are used interchangeably. So unless you're really designing the database and talking to somebody that designs databases, it doesn't really matter. If you're referring to an object in the database, you can just call it a table. I've seen people saying fact table and fact entity. So if you're talking about dimensional models, you can use the same language. So I purposely didn't go deep into dimensional data warehouse terminology for a few reasons. It's not where I focused when I learned databases. I learned in relational database management systems, actually Microsoft Access. It's not a dimensional model setup, so I actually never learned how to design databases from scratch there. However, I have queried them. Also, I find some of that terminology inconsistent too. But as a data analyst and data scientist, I've never had trouble querying data warehouses that are dimensional models with facts and dimensions. So I just think about them like a relational model, because basically if you understand the tables and the relationships between them, the SQL is exactly the same approach. So if you're reading a database and not designing a database, if you're doing a select statement from a database, it's not a huge deal whether it's a relational model or a dimensional model. It's the same kind of SQL. So I just don't want people to get bogged down here. So, don't worry about it too much. And I could put some resources in the description if you do want additional reading on that. But if you're here to learn the SQL, just don't worry too much about the dimensional terminology versus the relational terminology. All right, so now we're getting to chapter 2 and actually some SQL statements. So in chapter 2, you learn about select statements, some of the simple inline calculations and functions like round and concat, some things like limit and order by that control the display and sorting of which rows are returned. And then on page 29, it says that by the time you get to the end of the chapter, you should know what the two queries listed there do. So associated with figures 2.19 and 2.20. So we're going to go through those queries now. Okay, so the first query here, 219, it looks like this. Select star from farmersmarket.vendor. So if you've read the chapter, you know that what this means is select everything from the farmer's market vendor table. We're not filtering any rows, we're returning all the columns. So let's see how that looks. There we go. There's all the vendors in the farmer's market database. You can also notice that down at the bottom, it tells you what you just ran. So if for some reason you want to see what you ran and how many rows were returned, there might be more rows returned than you can see on the screen. And so you can get a count down here. All right, so now we have another Twitter question that will come into play right now. So I tried to get permission from each person who asked me a question on Twitter to share it. I asked kind of last minute, so this person hadn't got back to me yet, and I will link it in the description when they do. But their question is there a way to write the sample code without deleting the previous code? So you can see they have two queries there, and they can't run both because there's an error before the second one. So let me show you what to do in that case. Okay, so let's say here we wanted to do a second query. Maybe we just did the same one twice for a demonstration. You can see that you get this error before the second one because you can't have two select queries. It thinks that this is all one query. Because remember with SQL, you can have spaces and line breaks and all kinds of things. It doesn't mess up the syntax. So it assumes you're trying to write one query here when you really are trying to do two. Well, the solution is simple. You put a semicolon between them. So you can put it at the end or in between, it doesn't matter. But the idea is that ends the previous query. And when you want to run each one, see how it says, this button says execute the statement under the cursor. Whichever one your cursor is in, that's the one that's going to run. And so you can use your shortcut. I'd use Control Enter to run it, and it will run whichever one you're currently on. So let's go to the next query in the book, which it was saying that you should understand by the end of chapter 2. So in this case, we just are going to pull the name, ID, and type and order by the vendor name. So if you look at the query in the chapter, it looks like this. Vendor name, vendor ID, vendor type, and if we ran that, we get just those columns back, and then we have order by vendor name. So this will give us the same results, but it will now sort by this column. So there you go. So to explain what this one does, you would say it selects the vendor name, vendor ID, and vendor type columns from the vendor table in the farmer's market database, and we're sorting the output by vendor name. So at the end of chapter 2, there are 3 exercises, and like I said, the answers are at the back of the book. And so here's what the results for number 1 look like. Here's number 2, and then next you'll see question 3. And I'm putting the screenshots here because it's possible that the results you get from this database might differ from the results in the screenshots in the book. Okay, so the last question, which is going to come after this one, is going to have to do with troubleshooting something in MySQL Workbench, but I wanted to point out a couple more things for those of you who either are not using SQL Workbench, maybe you don't have a laptop to install it on, or you're doing this on a school tablet or something like that. I'm going to show you how you can run these queries on the website. And then I forgot to point out earlier, notice in the sidebar, you can see all of the tables here. So when I'm typing, if I don't remember the name of a table, I can look over here and look at all the tables underneath the farmer's market schema. So that's a benefit you get in SQL Workbench. But first I want to talk about the differences between MySQL, which is what's used in the book and in the example database, and SQLite, which is what I'm using on the book website, where if that's the only way you can query it, some of them will look a little different. So in chapter 2, there's this query that takes, you get the customer ID, and then it takes the customer first name and customer last name and concatenates them together with a space in between. So you get an output that looks like this. We aliased it as customer name. So if you're in the sample database in MySQL, you can type it in just as it is in the book. I encourage you to do that, to actually type it out and run all the queries in the book and get used to them. You can also play around with them and change them and see what the results are, how it's different. But let me show you what this one is going to look like on the website. So if you go to my book website, which is at SQLforDataScientist.com, in the upper left menu, you can go to Chapter SQL. You can also go to this interactive SQL editor, but Chapter SQL will get you what I'm about to show you now, which is example SQL from the chapters. So this is straight out of the book. It allows you to copy and paste instead of typing them in. So if you want a way to copy and paste some of those, you can. But there's a big difference. If you run the queries with the editor on the website, this editor is SQLite. Well, the database on the website is SQLite. So when you write SQL here, you're querying a SQLite database. Oh, I just copied that badly. So when you paste your query in here from the book, or if you typed it in just like the book, you would have used this concat function. Well, I try to note on each of the pages for each chapter which queries from the book won't work on the website because it's SQLite. So there's slightly different, we call them sometimes flavors of SQL for the different databases, and the syntax for SQLite slightly different. It doesn't have all the functions that you get in MySQL. It doesn't have a concat function. So if I ran this on the website, it would first say no such table, farmersmarket.customer. That's because in SQLite, this database doesn't have a schema. So I'm first going to remove the schema name. It doesn't know what farmers market is, but there is a customer table. But now it doesn't know what the concat function is. So that's what I pasted up here, a different way of concatenating in SQLite. So I'm just going to copy that line and replace it from the query I got out of the book, and you'll get the same results. Unfortunately, the error stays there just because the website, until you refresh it, it doesn't actually clear that error message. But you can now see you get the same results that you got in the book. So there is a way to practice the queries from the book, even if you don't have a computer with MySQL installed. So now to the last question. This was from Stephen Lancaster on Twitter. He followed the steps in the previous video and had some issues installing it because of Visual Studio, but was able to get it installed, but then had an issue when he went to create the model, the entity relationship diagram that we created in the last video. There were no schemas in the left sidebar to choose from. So the first thing I wondered is, was the database properly installed? Maybe there was an error when he ran the script from the website that we talked about in the last video. So the first thing we wanted to check was whether the schema existed. So in MySQL, there's a command called show schemas, and that will show you what schemas you have installed on your MySQL server. So I have a bunch, but this is the one you're looking for. So if you don't see stuff in your sidebar when you're in that other view trying to create the entity relationship diagram, come over here to a query window and run show schemas and make sure you see farmers_market. If not, then there might have been an error when you ran the script to set up the database. But if you see it there, which he did, then that's not the problem. So Stephen and I were going back and forth trying all kinds of troubleshooting, and Chris Perry responded, and he said, look, in any tab, this is in MySQL Workbench, you can click the database menu and choose reverse engineer, and then follow the steps there. So it's like a wizard, and it steps you through. So you select the schema, the farmer's market schema, which does show up there even if it's not in your sidebar, and just follow those steps, and it still gets you the entity relationship diagram in the end that I got when I was showing you in the previous video. So that worked for Stephen, and hopefully it will work for you if you have the same issue. And then all you have to do at that point is rearrange the tables to get the layout that you see in the book. So you have the entity relationship diagram, and now you can reference it on your own computer screen, much larger than you see printed in the book. So if any of you had trouble with the last video, this is potentially the solution. So thanks everyone for submitting questions online. This was really cool to get this interaction, and hopefully this supplemental content helps you as you go through the book. So your next task is to go through chapters 3 and 4. I was going to do kind of like a preliminary video and then a Q&A video for each chapter, but I think it works well to just have you all go through the book and then ask me questions either on Twitter, there's my handle on the screen, or on YouTube. Send me questions, and then I'll just do another video like this after chapters 3 and 4. So rather than 2 videos per chapter, I think I'll probably just end up with one slightly longer video for every 2 chapters. And yeah, I'm really enjoying this interaction, and hopefully it's enhancing your usage and learning from the book, and happy to answer any questions you have. So send them my way. Oh, and so chapters 3 and 4, let's say I want to give everyone at least 2 weeks, including 2 weekends. So let's say that the week of Valentine's Day, I'll start preparing for the next video. So get your questions in before Valentine's Day, February 14th. And then I'll probably release the next video for chapters 3 and 4 somewhere around February 19th or so. So yeah, you've got a couple weeks to read the next 2 chapters and do the exercises and ask me questions. Thanks. Bye.